Algebra 2.1. This is Mr. Carlson, C-squared mathematics. We are going to learn rational exponents. So this is wrapping up the week, rational exponents. We're going to get to bell work, homework quiz, and then through the lesson. I don't want to waste any more time. I have multiple slides. By multiple, I mean 2. I think. Yeah. So I have 2 slides. I have 2 slides I want to get through. There are going to be 4 questions. 4 questions I'm going to go through. And I'm pretty sure these 4 questions are on the homework quiz. Obviously different numbers, but hey, you may get lucky and you may get the exact same one. Wouldn't that be nice? So these are questions that I've already went through in the previous video, almost verbatim. So I want to go through them again, but just with different numbers to kind of explain the process so that you are adequately prepared for the homework quiz. Okay, let's get started. Now, this first one, I noticed a couple things here. I noticed I have a 3. It's an index of 3. This has an index of 3. There's a y chilling out here, but they both have some sort of number and then x. So right here, though, I noticed that this actually will go poofy with that 3. So now what I would have is y times the cube root of 16x. Okay, I don't want it that long, but 16x. That's what it will be. And then minus y times the cube root of 54 and then x. Now I want to simplify all this stuff. I want to simplify this 16. So let's do that. So this is 4, 4, this is 2, 2, this is 2 and 2. Since it's cube root, I want to circle 3 of these 2's. And so that means it comes outside. So this is 2 times radical, or 2 times y, and then times radical 3. Cube root of 2 times y times the cube root of, and then there's a 2 chilling in here, but there's also an x still chilling in there. Awesome. So now I have all that. Now what I'm going to do is I'm going to take this minus and try to figure out what this is. So 54, I take 9, 6. I'm going to take this as 3 and 3, and this is also as 3 and 2. And so I want to take those 3's, and then I'm going to combine it with this y out front right there. So 3y, 3 times y times the cube root of, and then I have a 2 chilling in here, and of course I have an x chilling in here. Now, when I have this, I start noticing a couple things, and I should notice that these are pretty much the exact same thing. Okay, when I'm boxing here, these are the exact same thing. What's different is the number attached to that, all those variables, specifically 2 and then negative 3. So since they're exact same thing, they're pretty much like a variable. So what I can do now is simplify those to be as such. 2 minus 3 is just a negative something. What's the variable? Negative y times the cube root of everything inside the radical 2x. So this is my simplified answer. Okay, that is my simplified answer. I hope we're feeling good about that. Okay, now this one I'm not going to do the long way. Okay, there's an easy way and long way. If you want to see the long way, it's probably more intuitive and maybe helps you a little bit more. You can go to the video previously of higher roots. But the easy way is this. How many times does 3 go into 13? How many times does 3 go into 13? Well, 4 times. So I have y to the 4th. And then what's left over? So I went in there 4 times, which makes 12. 3 times 4 is 12. And there's 1 left over, right, to get to 13. So I'm just going to have 1 right here. I'm not going to put the exponent of 1 right there because we don't ever do that. But you would. That's 1y left over. So that is my simplified answer. How many times does 3 go into 13? 4 different times. So y to the 4th times whatever's left over. 13 minus 12 is 1. So 1 more y left over in the radical. And then the index of 3, of course. So that is how you do that question. Okay? Let's erase. So this one, these are more like more review from the past. Okay? And so these are questions that I kind of just want to go over. I don't think they're going to be on the homework. Well, they're definitely not going to be on the homework quiz. So I may have misspoke. But these are questions that are still good to review, and they are on the homework quiz of some lesson, okay? So maybe I did misspeak too much. So these are just review. Let's take this, take an I out, and then the squared means double. Now I'm going to FOIL it. So this is 9. This is going to be plus 3i radical 6. Negative times negative, positive. 3 times I is 3i, radical 6. And then right here is going to be positive 3i radical 6, just like I had. And this is going to be a positive I squared. 6 times 6 is just 6. So this is 9. I add these up, so this is positive 6i radical 6. And this I squared is negative 1, so that means negative 6. And so this is 3. And then plus 6i radical 6. Because the 9 minus the 6, when I combine them together, give me 3. And that is my final answer. Okay, that's review. Good stuff. All right, right here, it is technically still review, so I'm going to go through it and fly through it. So this is plus I, and then radical 45. This is 9, 5. This is 3 and 3. So this is all over 24. So this equals negative 12, and then plus 3i radical 5 all over 24. Divide each one by 3, so this is negative 4 plus I radical 5 all over 8. And this equals negative 4 all over 8 plus I radical 5 all over 8. Simplifies down to negative 1/2 plus I radical 5 all over 8. This is my final answer. Boom! Solid! Happy days! You excited? I'm freaking excited. This is the last lesson I have to record this week, and it's amazing. All right, so let's move on. That's review. Helpful, right? Very helpful. So what should you be doing right now? The homework quiz. Okay, so you should be doing the homework quiz if you need to, if you don't have an A. So 30 minutes. I give you 30 minutes on this one because they're a little bit more tricky. That's all. And then 5 questions, of course. When you're done, make sure you review your answers so you can send any partial credit requests to me. That would be amazing, so I can help you. And this one definitely is partial credit request worthy. I mean, you can definitely forget a negative, forget a 2, forget an index, whatever. Okay? So make sure you send that to me. All right? After that, begin your Cornell notes. Rational exponents. Okay? Rational exponents. I actually really like this lesson. It's really nice. It kind of ties everything together. It ties radicals, it ties in higher roots, and it also ties in exponents all together in one. What do I mean by rational exponents? Well, rational just means not like smart or thinking clearly with logic. Rational just means fraction because of ratio. And ratio means fraction. So basically it's mean fractional exponents. Think about that, okay? Fractional exponents. So how do I simplify expressions with fractional or rational exponents? And how are they related to imaginary numbers? That's really what we want to ask. How are they related to imaginary numbers, and how are they beneficial to know when solving for imaginary numbers? Okay, that's the essential question. Let's get started. So before, I just want to show you this. This is Albert Einstein. What a hunk, right? I have 2 pictures of him on my room. I'm looking at it right now, and one of those quotes says this. I'm going to paraphrase. You need to know how to play the rules of the game. You guys play rules for your games all the time. You guys have games. You guys are probably playing games instead of watching this video right now. Okay? You're probably playing like Skyrim or like Fortnite or some junk like that. Maybe Call of Duty Zombies, or maybe some like Super Mario if you're really old school, right? Or just like, I don't know, Flappy Bird or something. It doesn't matter. Or you like maybe a board game, Monopoly. Maybe Exploding Kittens. Maybe, gin or poker. Or BS, the 52 card pickup game, whatever. Any game like that. You have to follow rules, right? Here's the thing. Math, it's freaking no different. Math is like love. It's completely irrational at times. But at the same time, it can be never ending. Okay, just like pi. Pi, the number pi, 3.14, it goes on forever. Okay, it's definitely irrational, but it's also never ending. And that's what I feel like math is. Why am I saying this to you? Because games bring us together. We love playing games, whether it's by yourself, video games, whether it's like a puzzle or whether it's with a family member. But the one thing that we always have to abide by are the rules, right? The rules of the game. If we don't abide by the rules of the game, okay, we get kicked out of the game. We lose. Okay, we die. Game over, right? Your parents catch you cheating, and then you're grounded for a month, and no chicken strips for you, right? I don't know. Okay, no ice cream. This is the point. Math is no different. We have to follow the rules of the game. If you don't follow the rules of math, you will lose. And by lose, I mean you will get a red X on Math Excel instead of a green check mark. Okay? That's literally what it is. So I want to preface this lesson with there's a lot of rules that you need to know and follow. And without following these rules, not only can you not really have fun, because I think math can be fun and it can be very invigorating and it's a puzzle. Okay, but also notice no description of our world can be had without mathematics. This is Albert Einstein, and notice there's tons of radicals chilling in here. 1, 2, 3. There's another. Where's another radical? Radical here, radical there. Like there's so many different radicals that he's doing when he's multiplying all this stuff together. And he's really going to town. That big E there is called sum. It's called summation. Okay? And so basically what this means, guys, is this. You cannot have a description of our world without radicals. Okay, I know it's covering that, but don't worry. It says something amazing. Okay, without radicals and roots. What does that mean? It means this. Radicals and roots essentially govern our world. And this is what we're going to be doing. We're going to be doing radicals and roots today. Okay? Think about that. One of these models describes how an astronaut in a moving spaceship ages more slowly than people on Earth. That's freaking interstellar crap. That's crazy. And it can be done with math. Okay? It can be done with math. So, what does the following expressions mean? Well, we obviously know 9 squared is 81, clearly. Okay, what about 9 cubed? 9 cubed, we learned the other day, is 729. Now, what if I have this? Whoa, don't know what that is. Okay, now if we plug it into your calculator, we do get something. We get something called 3. So it's almost like a way to write something like this. The square root of 9. So it's an easier way to write the square root. What does that mean? So that means this actually equals the square root of 9. This right here equals the cube root of 9. Or the cube root of 729. Okay? Or, wow, what am I doing? No. Forget that. I'm gonna show you. Forget that. That was dumb. Okay. But actually, I want to go back. Here's what I want to also show you. We're also going to do some other things, like such as this. So if I have 9 cubed, I know that's 729. And if I have 9 squared, I know that's 81. And if I have 9 to the first power, I know that's just 9. If I have 9 to the 0 power, I know that's just 1. Okay? But now think about this. What is 9 to the negative 1 power? Okay, and this is also something that we're going to be doing with 9 to the negative 1 power. What do you guys think that is? That's actually 1 all over 9. What is 9 to the negative 2 power? This is 1 all over 81. And how and why does this work? Similarly, how this works, we kind of denote this notation and invent that notation to mean that. Okay? How does this work? If I divide by 9 on every single one, think about that, I get this. And so forth. Okay, and so forth and so forth. Okay, and so that's why we developed this slight notation. We've developed this notation to help mathematicians. So I wanted to say that before we actually got into the actual lesson. What is it? So rational exponents, if n, like the index is n, so the nth the nth root of a represents a real number where n is greater than 2, so greater than a square root, then you have this, a to the 1 over n equals the nth root of a. So what does that actually mean? It means this. If I have, let me erase that. If I have 9 to the 1 all over third power, or 1 all over 3 power, 1/3 power, this means 3 as my index and then 9. That's what that means. Or better yet, if I have 7 all over to the 1/4 power, that means to the 4th root of 7. Okay? So this is what it means. So think about that, guys. Think. What happens to the denominator? The denominator of my fraction, my fractional or rational exponent, becomes my index. Okay? So the denominator of the rational exponent is the radical's index. Okay? So that is very, very important to make sure you write down. And then, of course, I have this part down here. This part is just kind of talking about the negative numbers. So if I have a to the negative 1 all over n, that equals 1 all over a to the 1 all over n, which means, if to kind of simplify, put in words, if I have 7 all over to the negative 1/4, this actually equals 1 all over 7 to the 1 all over 4. Okay, remember, negative exponents actually bring it down into the denominator with no more negative there, which of course equals 1 all over 4 to 1 all over the 4th root of 7. Okay, so that's how you follow that progression there in that order. Okay, that's what it would look like. So notice how the negatives are bringing into the denominator, but also the rational exponents will now become, and we can switch between rational exponents and radicals. So I'm going to be doing that a lot. Now that we have this idea in this math, I can actually switch between the radical over and over and over again, like the radical, to the rational exponent. And I can simplify doing that. So now it makes simplifying radicals so much more easy. Okay, I don't need to now have the same index. I can make them a rational exponent and then combine them as such, which is what we're going to be doing. So let's go to town on this. Let's start out sweet and simple. You can definitely plug these in the calculator by all means. You can go ahead and plug in decimals. I'm not going to, though. So this right here, 64 to the 1/2 power, that just means the square root of 64, which of course is 8. I'm gonna fly through these, guys. So the 1/3, 125 to the 1/3 power, that means it's 3, the cube root of 125. 3 is my index, and this of course equals 5. Okay, this right here, notice the negative is kind of out front. So now watch, this is a negative, and then the 4th root of 16. Notice what I did there. And this actually just equals 2, because the 4th root of 16 is 2. Okay? And that is part of the common higher roots slide from the higher roots page, or the higher roots video. So go back and go review that, because that is a common higher roots. Okay, for D, now notice the negatives in parentheses now. So what does this mean? This means the cube roots of, in parentheses, negative 27. Okay, I like to keep the parentheses there just so I can show you where it's going. So it's negative 27. Now, of course, since it's cubed, since it's odd, I can perform this action. It's not going to be imaginary at all, but it will be a negative, and that negative number is negative 3. This is also another popular common higher roots, but since it's negative, I have to make sure I attach the negative. How do I know it's that? Because if I take negative 3 cubed, I get negative 27, and it does check out. And I could do that for all the other ones, but this one checks out. I just wanted to show you that. Because it was negative. This one, what does that mean? Well, it means in the denominator, so 1 all over 64 to the 1/3. Okay? And of course, 64 to the 1/3 power is the 1 all over the cube root of 64, which of course is another common angle, which the cube root of 64 is 4. Okay, now that's how you simplify that. This one in particular is usually the one that students get hung up on because they forget the negative. or they forget that negatives bring it down below. When this happens, it becomes into the denominator, but notice there is no more negative. Okay, the negative is gone, and that's what you want. Okay, you want to get rid of the negative, so you put the negative, you put the whole thing underneath in the denominator, and that's what makes it. Now, sometimes you may be asking, and this one's for free, I'm not charging you. What if you have this, 64 to the negative 1/4, whatever, just random question. This now becomes 64 to the 1/4. Okay, so now it becomes into the numerator, but the negative is gone. Okay, so that is how you do that. If it's a negative in the denominator, move it to the numerator, positive. If it's a negative in the numerator, move it to the denominator, positive. The exponent is positive either way. Okay, and then the numerator and denominator get a 1 in its place. Just a 1 in its place. Awesome. Awesome, awesome, awesome. Okay, now that was the easy stuff, okay? Let's actually get to the harder stuff and then start simplifying stuff down with multiple different things. So after this, go through more examples, and then we're going to go through a lot of examples, even with variables, okay? So what do these mean? I'm going to show you what these mean right here. So this now is saying, what if you have an nth root of a, and that represents the real number, and m all over n. Not 1 all over n, but m all over n. Some number all over some number is a positive rational number where it's greater than 2. What does that mean? That means something like this. So this is a classic example, 2 to the 4 all over third power. What does that mean? This means this. Okay, now pay very close attention. It can mean either 1, it can mean this. So in parentheses, the cube root of 2, and then all to the 4th power. So it can mean that, and then of course I can simplify it as such. Or it can mean this, so 2 to the 4th, and that's what it means, okay? It can also mean this. So this is number 1, and this is number 2. Or it can mean this, 4 all over 3 equals, ready? So this is cube root of 2 to the 4th underneath. Okay, so it can mean either one, and that's the tricky part that students kind of get hung up on. Normally, I usually do it this way, but it depends, because it depends on if you can actually evaluate this. Like, I can't evaluate the cube root of 2, right? That sucks, right? But I can evaluate 2 to the 4th power. Okay, and that's 48. 2 to the 4th power is 48, and then the cube root of 48, I think is, I don't know. I can't remember what the cube root of 48. Let's find out together. It's probably some random number. Yeah, it's like 3.6. So it's some random number. I thought it was like 3 something. But yeah, so that's a lot easier to evaluate by hand than this, okay, regardless of the decimal. Now, furthermore, if you have the negative, of course, so an answer like this would look something like this. So 2 to the negative 4 all over 3. That equals 1 all over 2 to the 4 all over 3, which of course is the same thing as 1 all over, if I wanted to continue, 3 to the cube root of 2 to the 4th power. And that's if I wanted to continue, but I don't need to. So this is how you go through each one respectively, but the most important is this top part. You can break it up either in this way, with parentheses and then the exponent, or this way, the exponent with the base inside of the root, okay? But it depends. It depends on what you're given, and that's what I'm going to show you right now. So let's erase. Let's go through these examples. So A, 27. Let's switch to blue here. No, purple. Purple is beautiful. Actually, I haven't been doing orange in a while. Let's switch to orange. Heck yeah. The grossest color in the history of mankind. What does this mean? What this equals is 27. Okay, I can split this up a lot of different ways. So this is actually 27. Actually, give me a second. This is 27 to the 1/3 power and then squared. I'm going to show you what that means. That's like, wait, That has nothing to do with the last slide, Mr. Carlson. I know. Okay? Because I'm going to show you what this means in the next couple slides, and I like to introduce it right here. So the reason why I can do that is because what's 1/3 times 2? 1/3 times 2, 1/3. Oh my gosh. I tried to salvage it. Did you see that? Jeez. So 1/3 times 2 is just 2 all over 3, but that's the exact same exponent I have here. So I can actually split this up. And why do I do times? Because that's a power to a power, and a power to a power is multiplication. Okay, so in this case, I have the cube root of 27, and then in parentheses squared. Now, why would I want to do it this way? Because I can do the cube root of 27. If I wanted to do it the other way, watch, if I wanted to do it the other way, I would do the cube root of 27 and then squared. Now, 27 squared is a rather huge number. Okay, but then if I wanted to do 27 squared and then the cube root, it's not a huge number, it's 729, but it's still pretty big. That's a lot harder, I think, to do without a calculator. This, I can plausibly do it without a calculator. So the cube root of 27, that's just 3, and then I square that, and that's just 9. Whereas in this case, it would be the cube root of 729. And then, of course, it just equals 9. So either way you do it, it doesn't matter. You get the right answer. But this way, I did it this way using this option is because I can easily do the cube root of 27. So let's just do it here, right here. This is the same thing as, and there's multiple different ways I can do it. So watch, I can do 9 to the 1/2 and then cubed. So that, 9 to the 1/2, cubed. So this right here is the cube root of, actually, no, it's not the cube root. It's the square root. Getting confused. The square root of 9 and then cubed. That's another way I could write it. Okay. I can definitely write it that way. Or I can write it this way. I can write it in parentheses. The square root of 9 and then cubed. So either way, I can do it. So square root of 9 is 3 and then cubed, which is just 27. Okay? And then 9 cubed is 729, and then if I square root that, I get 27. Right? Just like what I did here. See? So it bounces either way. Like, it bounces either way. It doesn't matter which way you do it. Okay? Now, I'm going to stick to one consistent way here. This is going to be 1 all over 81, and then negative 3 all over 4. And this is 1 all over. I'm going to do the cube root of 81 here. Or sorry, the fourth root of 81. So that means I'm going to take it like this. So the fourth root of 81. Remember, the denominator is the index. The denominator is the index. And then I'm going to take that as cubed. Oh, sorry, I don't want to do a minus there. That's a positive. Okay, so what's the fourth root of 81? The fourth root of 81 is just 3. So this is 3, and then cube that. Of course, it's 1 all over 27. So you can kind of flip-flop back and forth and try to figure all these out. It doesn't really take too much to kind of understand, okay, the best thing I need to understand is this, that my denominator is my index. Okay, this is my index. Whereas the numerator right here is my exponent. Okay, that's the main thing you need to understand. And that exponent can be placed inside with the base, underneath the radical, or outside the radical. Okay, it doesn't matter. So like right here or right here, it does not matter. All right, so now let's get to actual like intense examples that you're going to see on Math Excel. Okay, so now what you see here is 8x to the 1/3 and then 2x to the 1/2. Well, first things first, I need to multiply these two together. Okay, well, what's 8 times 2? Well, 8 times 2 is just, 16. But here, what's x? I mean, this is really just x times x something. What do I do here? Well, notice that it is a product to a product. Now, when I do a product to a product, I don't want to multiply. I add exponents, which means I'm going to do a side note here. As a side note, I'm going to take 1/3 and I'm going to add that to 1/2. Okay, I'm going to see what this equals. and that's going to be my exponent, okay? So I already took 8 times 2 is 16. I already know it's going to be x, but now what's my exponent on the x? That's what I'm trying to figure out. So common denominators, 6, so times 2 gives me 6. 1 times 2 gives me 2. Times 3, 2 times 3 gives me 6. 1 times 3 gives me 3. So now what I have is 2 all over 6 plus 3 all over 6, which gives me 5 all over 6. Now I'm going to cloud this because this is like my side note here, which means this right here is my exponent. So that means I'm going to do 5 all over 6. This is my final answer. Okay? That was my exponent. Awesome. Okay? How are we feeling with that? I hope we're feeling decent. Okay, I hope we're feeling decent. So let's go through a different example right here. Notice how it's division. Now, since it's division, I'm not going to add, I'm going to subtract. But let's first get to my numbers here. So I can do this. 16 divided by 4 is 4, and I know it's going to be x. And so now I'm going to subtract these. I'm technically going to subtract 1/5. So let's do another sidebar here, 1/3 and then minus 1/5. Okay. 1/3 minus 1/5. So now let's go to town. So times 5 gives me 15 because that's my common denominator. And then times 5 gives me 5. Times 3 gives me 3. And times 3 gives me 15. That's what I want. So now what do I have? I have 5 all over 15 equals, and then, minus 3 all over 15, which equals 2 all over 15. That is my exponent, and this is my sidebar work that I must do. Now I can take that exponent and I can actually put it up there. So this is going to be 2 all over 15 as my exponent. That is my final answer. Okay? How are we feeling with that? That's division. Remember, we need to subtract my exponents. That's an Algebra 1 review topic right there, baby. All right, and then right here, it's going to be adding. Okay, I'm going to add because there's a product to a product. So let's review more exponents. Let's review more radicals, rational expressions. So I have a couple of them on here for us to get through. All right, so now this one right here. Now this is a product to a power, or what we call power to a power, because this is a power and that's a power. So we don't add them, we multiply them, okay? So that means I'm going to take x and then 9 all over 4 times 4. Now this is technically over 1, so all over 1. We simplify that, the 4's go poofy, so this is just x to the 9th power, okay? Nice. Nice, nice, nice. Okay. Okay, so this next one is sort of similar because it is still a power to a power, but it's a power to multiple powers. So what's interesting about this is that this 81 has a power of 1. Okay, and that's the thing that we need to understand. It has a power of 1. And I have to multiply this 1/4 to every single power. So the 1 to the 16 and to the 8. Okay, so what is it going to look like? It's going to look like this: 81 to the 1 times 1/4 power times x to the 16th power, and then times 1/4 power, times y to the 8th power, and then times 1/4 power. So that's what it's going to look like. Now, of course, 1 times 1/4 is just 1/4, so 81 to the 1/4. And then 16 times 1/4 is 16 divided by 4, which is the same thing as x to the 4th power. So that one's nice and chill. And then this one equals 8 divided by 4, because 8 times 1/4 is 8 divided by 4, which is the same thing as y to the 2nd power. So now what does this actually equal? Well, 81 to the 1/4 is the actual common angle. Common angle. Trig, that nasty trig, bleeding into algebra. It's actually a common higher root, which is just 3. And then, of course, I can finish out just writing the rest. Now, you could have written this as straight up, or not exponents, but as straight up radicals. You could have written it like this, times, and then you have the fourth root of x to the 16, and then times, and then you have the fourth roots of y to the 8th. You could have written it totally like this if you wanted to. And then you would definitely get the right answer no matter what. But now you see the radicals are kind of sloppy, a lot of writing, and they can get confusing at times. But now what you can do is you can use this knowledge of rational exponents and apply them instead of even touching a radical. So in this case right here, I can actually change this into an exponent. Okay, now obviously we already know how to solve this. How many times does 6 go into 12? Well, twice. So this is just straight up x squared. I'm already done. That's the answer. Or what I can do is now change it into a rational exponent. So I can change this to the x to the 12th and then times 1 all over 6. Because 1 all over 6 is really my index. Or I can better write it like this, 12 all over 6. Okay? 12 all over 6, which of course is x squared, which is the exact same thing that I got here. So you see, I can now almost completely get rid of radicals and just completely do rational exponents. How fantastic is that? Who loved radicals? Probably no one, okay? But rational exponents are way easier to use, way simpler. It's just you have to do with a fraction. And it's helpful to even add these or combine and simplify multiple different radicals when you combine them with rational exponents. Okay, so let's erase this. I have these two left and then one more slide. So let's go to town. I have these two right here. How can I do this? Well, of course, I don't want to do it that way. What I want to do is change it. I want to change it into an exponent. So how do I do that? Well, I can change it into exponents by saying x to the 9th power times y to the 3rd power, and then all the way to the 1/12th power. 1/12th power. So I can translate it into that. Then I can multiply it through. So I can do x to the 9th times 1 all over 12. And then I can take times y to the 3rd times 1 all over 12. That's what I'm doing. It's power to a power. So 9 all over 12, when I simplify that down, 9 all over 12, that actually gives me, if you want to do it off to the side, you can. This gives me 3 all over 4. So this is x to the 3 all over 4 power times, and then 3 twelfths, what does that simplify down? That simplifies down to 1/4. So this is y to the 1/4. So now, what does this simplify? Since it gave us it into radicals, I want to simplify it back into radicals. So how do I do that? Well, I have to simplify it back into radicals. So what this really does mean is that since they're both underneath radical 4 now, this is radical 4, or the 4th roots, since they're both underneath the 4th root because the index, the denominator is both 4. So the 4th root of x cubed times y. So this is now my final answer in a radical form. So you see how I'm kind of going radical, exponents, simplify, and then back to radical. That's what I want you to do. That's how you're supposed to do it. If they ask you to put a radical and you put the rational exponent form, it will mark you wrong. Why? Because they want you to do a radical. You're trying to figure out and trying to see the relationship between rational exponents and radicals. You can't do that if you just translate this to a rational exponent and then you don't translate it back to a radical. You need to translate it back to a radical as I've shown here. Okay? Just know the key factor is this. The denominator is what makes the root. Okay, I know that that's the denominator, and then the 1 right here and then the 3 right there is the exponent to that base. So the 4 and then the 4 is the root. So root 4, they're both underneath root 4. What's the exponent of x? 3. What's the exponent of y? 1, which we don't write. That's my final answer. So let's try to do it here. Okay, and then I'm going to actually combine it probably into a fraction after that. Or not fraction, but radical after that, but I may not. But you also have to do it to the 9. So remember, the 9 does have an exponent here. So I have 9 to the 1/2 times x to the 8th power to the 1/2. Okay? And then I have times I have y to the 10th, and then to the 1/2 power. Now, 9 to the 1/2 power is just square root of 9. Okay, so I'm going to show you this. It's just a square root of 9. Yeah. 3. I'm blinking. I don't know if I want to show you the radicals. I'm probably just going to jump right to it. As I gave you in rational exponents, I'm not going to give it to you in radicals. So that's just 3, and then times, and then this right here, 8 divided by 2, or 8 times 1/2, is just x to the 4th power, and then this right here is y to the 5th. So my answer is 3x to the 4th, y to the 5th, all simplified out. Okay, what this does look like, I'm not going to simplify it, but what this does look like is really just a square root, okay, of 9x to the 8th and then y to the 10th. That's really what it looks like. And of course, it does simplify to that. Okay, so again, bounce back and forth between radical and exponent. Let's move on. Get this down, pause it if you need to, but I'm going to erase. Okay, application question. So what it wants us to do is find the perimeter and the area. Find the perimeter, shoot, that's my first step. And then I want to find the area. Let's do that in blue. Find the area. That's my second step. So what's the perimeter? Well, the perimeter is really easy. It's just adding up all the sides. Now, since this is a rectangle, this is nice because these are all congruent. So if you remember your congruent symbols in geometry, that's what it looks like. So my perimeter for my first step equals, I'm going to have radical 216 and then plus radical 216 because I have two of them, right? This is technically radical 216 down here, and this is 2 radical 24, okay? And then I have plus 2 radical 24, and I have plus 2 radical 24. And of course, this is all in feet. So now I need to simplify all this stuff. So radical 216 is 24. If I divide by 24, I get 9. You can do divide by 2, you do whatever. Divide by 4, whatever. It doesn't matter. And this right here is going to be 12. This is 2. This is 3 and 3. This is 4 and 3. This is 2 and 2. Since it's square root, I want pairs, right? So this is 3 coming outside. So 3. And then this is 2's coming outside, so times 2. And then I have a 3 and a 2 left over, so it's times 6, which is times each other. 3 times 2 is 6, which is underneath the radical. So I have that. I have a 6 radical 6, which will reduce down to 6 radical 6. Okay? Perfect. Okay, now I know that this is going to be the exact same thing here, so I'm actually just going to simplify that down to be 6 radical 6 because I know it's the exact same thing. Now how do I do 24? This is going to be 12, 2. This is, let's just do 6 and 2. It doesn't matter. And this is 3 and 2. Since it's a square root, I just want 2 of them, and that's going to remain 3 times 2, which is 6. But I still have a 2 chilling out front, right? So 2 times, bring out another 2, and then I have a 6 underneath. And then this is going to be the exact same thing, right? So I'm actually just going to copy literally the exact same thing down because I know it will simplify down to be the exact same thing because it's the exact same side, right? So now after we simplify this, I have 6 plus 6, which is 12 radical 6. And then 4, this is 4, 2 times 2, which is 4 radical 6, and then plus 4 radical 6. So let's combine them all. 12 plus 4 is 16, plus 4 is 20. So this is 20 and then radical 6. I can combine that because they all have the same radical. They all have the same number underneath the radical. So that's my perimeter. Fantastic. How do I do my second step? I'll do it right up here. How do I do the second step, my area? Well, my area, if you remember, for a rectangle is length times width. Okay, that's my area. So I really just have to take 216 times 2 times radical 216 times 2 times radical 24. So that's what I'm going to do. I'm going to take radical 216, and then I'm going to take this 2 and then radical 24. Now I already know, that's the awesome part about this, I already know the simplified versions of these. What's the simplified version of radical 216? 6 times 6 times radical 6. That's the simplified version. And then the simplified version right here is for 2 times radical 24. So that means 4 times radical 6. Okay? So that means when I multiply it all together, what is 6 times 24? Well, that's going to be 24. And then what's radical 6 times radical 6? Well, that's 6, which equals 124 feet. And since it's area, squared. That is going to be my final answer. Okay? So neat little application question that I kind of threw in there. Look at me. I'm awesome. Okay? I'm so legit. Now, I'm going to erase, so make sure you get this down. Pause if you need to. What did we learn? We learned one little thing. How to understand and use rational exponents. I guess we learned how to also apply it in certain application questions too, at least in that one application question. But that's the only thing we learned, just how to use rational exponents. So, of course, don't forget about missing work, but don't forget about also the retake for the Unit 1 test. And then also, make sure you like and subscribe to my channel. This is C Squared Mathematics. If you have any questions or concerns, please let me know, because I'm here to support you. I'm here to help you succeed. So please let me know. Por favor. I'll see you guys later.